Well, my wonderful award-winning calculus video series continues. This is Unit 5, Part B, numbers 2A through D. It has to do with mosquitoes. And I actually miss those little guys. That means that I'm outside and it's warm out, and I'm doing usually something fun when I'm getting bit by mosquitoes. Four parts of it. Part A says you correct units interpret the meaning of m prime 15 equals negative 171. All right, so m, I should have written this down, is negative t cubed plus 12 t squared plus 144t, and t is between 0 and 18. So the number of mosquitoes on the field after major rainfall is modeled by that. T is the number of days in rainfall after the rainfall ended. Okay, so what does m prime of 15 equals negative 171 mean? That just means the rate of change at 15. So after 15 days, mosquito rate is going down 171 mosquitoes per day. Okay, so it's just going down at 171 mosquitoes per day at t equals 15 days. All right, part B. Based on the model, what's the absolute maximum number of mosquitoes in the field over the time interval from 0 to 18? Okay, so find our critical points by finding m prime. Negative 3t squared plus 24t plus 144. I'm going to take out a negative 3. 48. All that factors. If you set it equal to 0, we're going to get 12, and we're going to get negative 4. All right, so negative 4 is not in the domain given by the problem, so that's not an option. So t equals 12 is the only critical point in the interval. I should always check endpoints also. So we're going to try to find out what m of 0 is, m of 12 is, and m of 18. Okay, so those are going to be your maximum. Your maximum is going to occur in one of those three spots. Well, m of 0, no mosquitoes. M of 12, plug it in. Let's see what their answer says. M of 12 gives you 1,728. And M of 18, oh boy, I should type that in. Is some number that is less than 1,728. Okay, so we could plug in 18, and it's going to be smaller than this. So our maximum in the interval is going to be 1,728 mosquitoes, and it happens at 12 days. You could do the second derivative, and plug in 12, and it's going to be negative, which indicates that it's going to be a maximum at that point. So if that's a maximum, if you're just looking at the graph of 0 and then 12 and then 18, it's going to go like this. So it has to be the maximum at 12 because it's concave down. So 1,728 mosquitoes is the max in the interval. Part C. What are the values of t is the rate of change of the number? For what values of t is the rate of change of the number of mosquitoes in the field increasing? Okay, the rate of change of the number of mosquitoes. Where is that increasing? Okay, so we have our first, we want to know when the rate of change is increasing. So that's when your second derivative is greater than 0. So if m prime is this, m double prime, negative 6t plus 24, that has to be greater than 0. So one way to do it, I think what they did is they set up an inequality. Where is that greater than 0? You can solve. Add 6t, divide, so t is less than 4. So in our interval, it starts at 0. and it goes to 4. So you could say the answer be between 0 and 4. They include 4. You would get it right if you did not include 4. It doesn't matter. Both would be acceptable on the AP exam. Okay, so that's the interval for part C. Part D. Let's see. What does it say? From 0 to 18, the number of bats in the field is modeled by the differential function b, where b is a function of the number of mosquitoes. So b is a function of the number of mosquitoes in the field. Well, m represents the number of mosquitoes in the field. So b is a function of m. Based on the models, write an expression for the rate of change of the bats in the field. Okay, so we need to define b. B is some function of m, which is a function of t. So b of m of t. So that's what b is. Now we can find the derivative. So b prime equals the derivative of b times the derivative of the inside, which is m prime of t. All right, so b prime of m of t, which is right there, times m prime, which is right up here, okay, so there is the rate of change of b in terms of t. And then the only thing is they want to write in when t is equal to a. So our answer would be same thing with a's in place of the t's. There you go. Thank you very much.